The theorem that you're gonna do now states that if angles are subtended by the same arc or the same chord, the angles are equal. So you remember from the first video of our in this topic, Euclidean geometry, we learned about the terminologies that you're gonna use throughout the topic, Euclidean geometry. So let's say now we have this circle. We have this circle and we have a chord called A, B. So a chord is a line drawn from the other side of the circumference to the other side of the circumference, that lies within the circle. So let's say we have chord AB now. Chord AB subtends an angle to the circumference. So it subtends an angle. It forms an angle to the circumference. You see, this is the angle. Let's call this angle C. And then again, chord AB subtends another angle to the circumference. It subtends another angle to the circumference, of which this angle now is what? Angle D. Let's call him D. You see, so this angle and this angle will be equal since they are subtended by chord AB to the circumference of the circle this side, and also AB subtends another angle to the circumference of the circle. So this is a chord. Also, it applies when they are subtended by the same arc. Let's say now we have arc PQ. So the arc, you remember what an arc is, right? So this is an arc. Arc PQ. Let's say PQ subtends an angle to the circumference of the circle. You see? And then it also subtends, let's call this R. And it also subtends another angle to the circumference of the circle. Let's call this S. You see? PQ subtended S, R, and then it also subtended what? It subtended S. That means angle S is equal to angle R. But if we look carefully, we can see that SR is also a chord. SR is also a what? A chord. An arc, sorry. It's also an arc. SR subtends an angle Q. It also subtends another angle P. You see? So that means P and Q are equal. P and Q are equal. But it does not mean that these angles equal these angles. Remember, they are equal only if they are subtended by the same chord or the same arc. In this case, SR subtends P and Q. And then in this case, PQ subtends S and R. So these two are equal and these are equal. But that doesn't mean this, all of them, all four together, they are equal. So your reason in this case for saying this angle is equal to this angle. So I'm not going to prove this theorem. For saying this, but if you want to prove, you can just say it on the comment, then I'll make a plan for you. S is equal to angle R. Your reason will be that they are subtended by the same chord, same arc, Angle R, angles subtended by the same arc. And for you to say angle D is equal to angle C, you'll say they are subtended by the same chord. angle D equals to angle C, angles subtended by the same chord. And then now if we remove the chord, we still have angle D equaling angle C. What's the reason? We can see that now AB is an arc as well. You see, AB is also an arc. So in some cases where I don't know if you can differentiate or you can't differentiate a chord or an arc, the easy way to say these angles are equal, it's either they are subtended by the same chord, either they are subtended by the same arc. You can put them in one bracket and say angles on the same segment. So this means that they are subtended by the same arc. It also means that they are subtended by the same chord. So if you don't know if it's an arc or a chord, but you can see that these angles are equal, or maybe it was like this, you don't want to say an arc, you don't want to say they are subtended by the same chord, you can simply say angles on the same segment. Okay, let's take for an example, not an theorem that states, assume these are two equal chords. A, B is equals to chord D, C. Assume they are equal. So this chord subtends an angle to the center. You see, chord A, D, C subtend an angle to the center. This is center O. And then another chord, the chord that's equal to this chord, chord AP, subtends another angle to where? To the center. So these angles will be equal. This angle will be equal to this angle. Your reason of saying that is that you'll say, let's say O1, O2. Angle O1 is equals to angle O2. Angles subtended by equal chords to the center of a circle. So I can just simply say angles subtended by equal chords and end it here. Or if you feel that you have enough energy, you can continue say to the center of a circle. But once you say angle subtended by equal chord, then we'll get what you mean. So let's look at some examples then. Let's take for an example. Now they want you to find, they say find angle D and find angle O1 and find angle B. So our first approach, we'll find angle D. So we know that AB is an arc. We can see that AB is an arc. So we see AB subtends an angle to the circumference and also subtends another angle to the other side of the circumference. So that means angle A is equals, angle D is equals to this one, since they are subtended by the same same arc. So angle D is equals to 40 degrees. Angles on the same segment. And then now we have here 40 degrees. So always, even if you are given a question paper, once you get your value of the update your sketch, write down the value that you've got. Let's say you got 40, you update it, now it's 40 degrees here. And then what's angle B? We can see that CD is an arc. This whole thing is an arc. It subtends an angle to A, also subtends another angle to B. But A is 20, that means B is 20 as well. B is 20. Your reason is the same. Angles on the same segment. And then now we have 20 here. We want to find angle O1. Let's say this is angle O2. We want to find angle O1. But if we look at the triangle BOC, we can see that we already have two angles of the triangle. We only left with one. And then what we're gonna do, say angle O1 plus B plus angle C equals to 180. Angle O1 plus angle B is what? Is 20 plus angle C is what? 40 degrees equals to 180 degrees. So 20 plus 40 is what? Is 60. Take the 60 to the other side. 180 minus 60, you get angle O1 being 120 degrees. And what's your reason? Your reason here is sum of angles in a triangle. And then now you got O1 to be 120 degrees. What is angle O2? Angle O2, you can do the very same thing that we've done this side. Or you see that this is a chord equals to another chord. Chord AD is equals to chord BC. They told you that they are equal with this thing. This represents that, or they tell you that the chords are equal or the lines are equal. If maybe it's not a chord, it's just a line. So this tells you that they are equal, or they can be like this. They're showing you that the lines are equal. So equal chords subtend an angle to the center. That means those two angles are equal. This chord is equal to this one. They both subtend angles to the center of a circle. That means the angles that are being subtended by equal chords are equal as well. You see, it subtends an angle to the center. This is 120. And also this chord subtends another angle to the center. So that means also this angle is 120. That's angle O2 equals to 120. Angles subtended by equal chords.